Hi everyone. Hi Azure Cosmos DB community. I am Hasan Savran. I have truly enjoyed meeting many of you at past conference, and I cannot wait to make new connections and talk about Cosmos DB at upcoming. Today, I'm going to talk about the data modeling with you, and I'm going to try to make it interactive as much as I can. So I have no slides for you today. We are going to work on the VS Code as much as we can. And we are going to actually look at the Stack Overflow data model and try to move it to Cosmos DB and make it scalable and very affordable. Currently, it's in the relational database, so we are going to take it from there and move it to Cosmos DB by using different VS Code extensions and tools. So I just want to kind of show you how I guess I handle when I get a project like this. So I guess before we move to the VS Code, let's look at what we are dealing, right? So we have limited time, so we cannot kind of look at all the Stack Overflow tables. So we are going to actually focus on the busiest part of the application, which is we display the questions, and we are going to go and click on a question and get all the answers, right? Sounds simple, but as you can see, there's all things are going on here. So we have like question, we have answers, we have comments, we have badges, we have votes. So we have, potentially a large application page to display here. So this is what we are going to tackle today. So let me go back to my VS Code, and let's start from the relational database where the data is actually currently at. So these are the tables we are going to tackle today. So we have the post table here. As you can see, it has a bunch of kind of like a columns here. We have each post can have multiple comments and multiple votes. We have the users information, and users can have number of badges. So in a relational database, you can easily join these tables together and really deliver whatever the query is asking for. But we are going to go to the Cosmos DB, which we don't have any more joins. So what are we going to do? Well, before we jump, what we are going to do, let's talk about what we shouldn't. We shouldn't just take this as it is and move it to Cosmos DB. This is not going to work because we don't have joins in the database side. So you have to kind of go and join each of these, data in your front end or in the middle layer, which is not going to be easy. So let me actually show you if we will actually take this as it is and put in Cosmos DB, what is going to happen. So I have a bunch of the different databases here. So what the application we are seeing here, this is the one that I created. It's available in VS Code extension. It's just for the Azure Cosmos DB community. It's free. You can download it. So what I'm doing here is I'm just picking my database. As you can see, all these tables that I just showed you, they are here available. So we are going to go and start with probably the posts table. So first, we have to go get the questions and answers. And the post table has both of them. So I'm just going to go and actually go pick this one. Click. Before I click to execute, actually, there's a good function here I can. So I'm just going to run my query analyzer here so I can track how much everything is costing to me later. So the first, we are going to go get the questions and answers. As you can see, it looks like we have three. I'm guessing I have one question and two answers here. As you can see, it cost me 3 request units. Okay, not bad. But we are not done yet because we have many other stuff that we actually have to go and get, like comments. So to get the comments, we kind of need to use the in here because we are dealing with 3 objects, so we have to pass their post ID and get this information. So let's go and get that too. That cost me 337. Okay, not bad. But now we are going to continue. You might need to get the votes or maybe try to count the votes and display them on the page. So we need this information too. Another 3. Then, as you saw on the page, there are some user information. So I need to go and get the users for these questions and answers. I'm going to go and get those. Another 3 that I have to get paid for. Then I'm going to go and get the badges. I may need to maybe count the badges of each of these users, display emojis or whatever, depending on what they have. So I need to get that information too. Well, what's happening here? Looks like I have 277 badges, and it actually cost me 16. request units. So if I'm going to go back to my query analyzer, this is really what's happening. Just to display one page, I need to sum it up all these request units. I couldn't join any of this data in database level. So that's going to be like my problem to solve in front end or in the middleware. So that's why you don't want to get a relational data model and move to Cosmos DB as it is. It's not going to be a good for feature or for today, as we can see. It's gonna as the data is gonna get larger, if the traffic is gonna get larger, it's gonna get cost you more and more. So what do we do? Well, what do we do is pretty clear. We need to reduce the number of containers. So for that, let's actually look at this diagram here. That's where we are right now. We want to try to write and read data, but currently we have 5 containers. We only look at the read. We didn't even look at the write. So if I want to look at the write, I can quickly do that here. So let's actually try an update. So I'm going to just update a post. I'm just increasing those numbers here by using the patch operation. So let's see how much this is going to cost me. 15 requests. And that's only one container. So, things can get really expensive really quick with this. So as I said before, we want to, reduce these numbers, the number of the containers here. So what are we going to do here is, well, we have the post ID is the partition key in each of these containers, as you can see. Now, the good news is we have the post ID for getting shared by these 3 containers, and the user ID is getting shared by these 2. Since they share the same partition key, why don't we just put them in the same container, just like the version 2 suggests, right? So we have a post, our partition key is post ID, and each comments and was is going to be under the same post document. Sounds good on paper. We can try it. Also, that applies to the users. So rather than we have 5 containers, we end up with 2 containers. So let's try that. Let's see how this is going to work. So I'm going to go and change my data model to 2 here. Go back to results. And as you can see, I have only 2 containers now. So let's start with the post. Well, for that, I'm going to run or execute the same exact query that I just ran. So let's see what's going to happen here. Execute this one. It cost me 3 request units. But this time I got all the information. I have the questions, I have the answers, I have the comments, and I have the votes. And if you look at the document size, 5.71, really not that bad. The good part is if I actually go scroll down, you're going to see everything is already mapped. So I know that these votes are for this question, these comments are for this question. So everything is really kind of ready to render in the front end. So I kind of like that. The next one, this is, I think, the answer. There's no votes and comments. Great. The third one, let's see what's going on here. Ooh, that one kind of gives me some red alerts here. Why? Well, look at the number of comments we have here, 21. So, which tells me the relationship between the post and comment is not 1 to few, it's 1 to many. Which means if comments are going to grow and we don't have a limit for it, then that means that we are going to have an issue in future for sure. This is great for today, but you really need to worry about the feature too. When you start to have more data, more traffic comes into your database. So I know this costs great, 3, but I don't think that this idea is going to actually work for this data model because in future, we will have issues. Well, let's look at the users table too. I guess that was only the post. So this is my user table. Let's execute it. Let's see what's happening here. Again, 299. I have, looks like one user here. But look at these badges. I have 54 badges, which kind of tells me that maybe users can get the same badge multiple times. Then this is not going to be easy to kind of keep them under the one object like that. So this is a one-to-many relationship too, and it really just doesn't make sense to me, especially for a feature to put them in the same place. Mainly because it's going to actually increase our data model, and there's going to be no limit for it. So if I'm going to actually go back to my diagram and try to maybe talk about the sizes. The size is important. As you can see, the data model size, you have a limit for it. 2 megabyte is the limit. It cannot be larger than that. And your data model, as long as your data model getting large and large, that means that your cost of the query is getting expensive and expensive. Same with the write, because well, Cosmos DB needs to handle many more properties, and it's gonna cost you more. So whenever you create a data model, you want to be like give some kind of estimate how big this data model is gonna be. So if your data model is gonna continue growing and growing, probably you're going to hit that 2 megabyte limit, and your solution is going to get more expensive and more expensive every year as data grows and traffic grows. So because of that, yeah, it's a good kind of it give me a good result right now, but for future, I don't think that I can end all this under the two documents or the two containers. So what do? Well, one thing, we are going to roll back. But we really cannot roll back to that because it's not really cheap either. The good news is, well, we are still, I guess, sharing the same partition keys here. And I'm not sure if you notice one thing here. There is actually a nightmare here waiting to happen too. So if you look at our select statement, it says post ID is this number or parent ID is this number. So the first one is giving you the question. The second one is giving you the answers because both of them are actually in the same post table. The problem is the post ID is the partition key, parent ID is not. So as soon as right now we have all data in one physical partition. As soon as you start to distribute this data, this query is going to become a cross-partition query, and it's going to get very expensive very quickly. So we need to do something about that too. So what do we do from here? Well, we can try the document type data modeling. Document type data modeling is working a bit different. So we still have two containers here, host documents and user documents. But rather than saving only one entity type in the one container, we want to save different types, and we want to control that with a new property named document type. So I can easily figure out which post is question, which post is answer by looking the post type ID. So I just change that and add question and answer document types in this post. So I can easily, for example, when you click the question, that will be your question ID. And by knowing the question ID, I should be able to get all the questions, all the answers, all the comments, and all whatever really from this container. So this might actually work very well for the situation. Same with the users. You can just get the user information, or you can get the badge, or you can get all. And the other part that I really like about this one, this is open. So if you have different kind of document types later, you can continue adding here rather than creating new containers. So let's see how this is going to work. I'm going to go back to my Cosmos DB NoSQL Studio, change my data model to data model 4, and let's start with the post document first. Now, as you can see, I don't have the post ID anymore. My partition key is question ID. And if I want to get only the question for this, for example, question, I can run this and just execute this one here. And this will give me only the question, 2.94. Not bad. I can get only the answer here too. I will execute this one, 296. As you can see, I have only the answers because I have two answers here. Or I can get everything. I don't care if it's a question, answer, comment at the end. I need to render this in some way in my front end. So I can just do that and look at it. It's beautiful. You know what is beautiful? This is beautiful here. The cost is 3.61, and I was able to get everything, 29 items with that much request. So this is really very scalable and very affordable solution. I am really happy about this one. So as you can see, I have some answers here. I have some comments here, and you can easily look at the document type and render that in the correct places in the front end, or if you want to kind of use a factory design and kind of put them in your the C# object or anything like that, you can do both. So this is working great. I'm really happy about this one. Now, next is usually developers will kind of stop here. Why? Because probably that was a requirement. Create a like a scalable, affordable data model, which we did, right? Well, I will suggest you not to stop there because there's all kind of other things that you can still work on, and those are what about the feature? What is going to happen in the future? How can I make this data model better so it can tackle the problems is going to come in the future for the system? So for that, there are a couple of options you can actually look at. The first thing I can look at is probably the tenants, right? So yeah, we have only Stack Overflow questions today. But as you know, Stack Overflow got much bigger. There's a Stack Exchange. You can actually take this, questions and answers and apply to different domains, and they can talk about the totally different questions and answers. So therefore, it will be a different UI, but in the backend, it will be the same. So we can really easily make that ready if we actually add the tenant ID to our data model. So we can do that. And if we are going to do that, then that means we can actually use the hierarchical partition key. Currently, we are using only regular partition key, which is the question ID. So if I'm going to do something like that, what is that going to look like? Well, all I need to do is I need to go and create a tenant ID in here. And whenever I'm asking the question here, I'm going to add the tenant ID 1 and question ID is this. So really, that's what my select statement is going to change into. And when I run that, it should run just fine. Let me go data model 5 first. As you can see, I have the data, so it's still 305. And if you actually go to Cosmos DB info tab here and look at the overall, look at the partitioning here, my partition key is the tenant ID and question ID. So whenever actually I ask this question ID, let's say we have two tenants, one is about the C#, other one is maybe the farmers who's asking a question if how their chickens are can do better. So in this case, if you're going to tenant ID 1, we are only search the C# question. We are not going to search for farmers question in that case. So you can easily change the where the actually you are looking by changing the tenant ID here. So I like this one. This will be actually make the system ready for multi-tenant systems. What else we can do? Next one is find questions. Now you're going to say, well, Hasan, this is great, but how are you going to find these questions, right? So the question is already in the page. You click on it, but users need to find these questions in some way. So there are two things I will suggest for that. In older days, we used to have like categories. We used to have tags. Users are supposed to go and click the category, find the products, what they need to find. But well, the things that change very quickly, right? So right now, everybody likes to chat. Everybody likes to write, what they need, and they're supposed to go and find whatever they are looking for. So for that case, what we can do here is Cosmos DB has two options that you can easily set up. The first one is full text search. In the full text search, all you have to do here is you have to go and look at your full text policies. You just need to define which language the data is in post body. That's where my data is. All that description about the questions or the answers, and I just create a full text index on it with the post body. After that, after reindexing is done, all I have to do here is I can use the full text contains. That's one of the functions for full text, but this is one of the easiest ones. So I'm looking for the questions. I'm looking the post body, and I'm looking for if it has any SQL Server in the text. So if you can see, the post body is a pretty large text. So if I'm going to go run this one, and if the user goes and writes SQL Server and search, this is what's going to happen. This is going to find top 10. And as you can see, the SQL Server is in the post body out there. I'm just giving the title here. And the best part is, look at the cost. It really didn't cost us that much to make a search like that. Next one is the vector search. So the vector search, in that one, the user is really not looking specific words anymore. It's looking maybe like looking for a relational database operation problems, for example. So you have to go and find MySQL, PostgreSQL, and all kinds of stuff. So if that is the case, the first thing you need to do for that is you just need to create vectors. And as you can see, I created policies here. You just need to give some information about the model that you pick. And then this is my indexes. Interestingly, there's another actual options here, which I don't show it, but you can actually see in the Azure portal. That is the shard ID for the vector index. So in that case, we have tenant 1 and 2, right? So you can easily create those indexes, and the indexes will distribute it by the tenant ID. You can actually write that. So whenever you make the vector search, it can search only that tenant ID. So it will make it much cheaper that way. And Discan is actually supporting that. So that's why I kind of like the Discan indexes. Anyway, before we go more details, I go more complex. Let's see. Also, this application is going to make the vector search much easier, because before you make the vector search, you need to generate the vector itself. So as you can see, if you have a vector policy, I have this vector search option here. You just need to go, and this is going to go and discover all the AI policies you have. And I have this embedding model, for example, and this is the data I want to vectorize or search for. Relational database performance issues. You click vectorize it. It calls and creates the embedding for you. You can actually easily see it here. So this is the text, and this is the, well, all that numbers is the vector I'm searching for. So I can easily use this embedding parameter. Before I click on running that, I hope you notice one thing here. Look at the document type. It is post vector. So I am not searching the whole database. I'm only searching for document type. So that actually makes my search much lighter. And I'm passing the tenant ID too, so I won't kind of go and search for farmer stuff, I guess, in this case. So click and execute. And this is going to cost a little bit more, because this is much more complex than looking for the word. As you can see, it finds MySQL, it finds SQL Designer, insert problems, dynamic SQL store procedures in Oracle. It's much more complex than the other one that I just showed, but it's available, and you can easily use that too. All right, the other three things that I can just talk quickly is schema versioning. You should have a property for the schema versioning out there, and every time the schema changes, you can just increase that. And you can use that property to, like if the business workflow changes from schema version to other schema version, you can actually handle that. Retention, you should really look into that because Cosmos DB should have only the hot data. If you don't care about that data anymore, you can just take it out and put it somewhere much cheaper. So that's going to make your data size smaller, and that's going to make your storage size much smaller, and things going to work much better. For that, you can use the TTL function of Cosmos DB. For example, if you don't care about the data after 2 years, well, you can easily make the TTL 2 years, and Cosmos DB automatically will delete your data after 2 years for free for you. So that will be a great thing to ask to all the the requirement, whoever give you the requirement, what is your retention policies for that. The last one is the analyzing data. We create a great operational database data model, but at the end, somebody needs to analyze this data. So we will see how the business is doing. So for that, Cosmos DB has the mirroring data to Fabric, and you can easily turn that on, and data analysts or BI developers can easily kind of go and look at the data and analyze the data and create reports from it. So those are the things that you should really kind of consider and think about in the data modeling side. Well, that's all I have for you today. I hope everybody learned something new today. If you have any questions, you can find me on the LinkedIn and Twitter, or any other social media, social platforms, and I'll be more than happy to help you from those areas. Thank you, everyone. Thank you for coming to my session.